Hello, welcome to lesson 2b of reaction rates as we look at the effect of surface area on rate of reaction. In lesson 2a, we had considered that if we have a whole particle and work out its surface area, then its surface area is relatively small, even though the body looks big. But if we were to cut up the same particle with its same dimensions, then we realize that this time the surface area of the resultant exploded particle becomes large. In this way, we had said that by grinding or cutting up a particle, then we increase its surface area. We had begun looking at magnesium reacting with dilute hydrochloric acid. In this case, the whole particle could represent magnesium ribbon. The cut particle could represent magnesium powder. How can we use magnesium ribbon and magnesium powder to demonstrate the rate of reaction with hydrochloric acid? How can we measure the rate of this reaction so that we can indeed make this observation that powdered magnesium will react faster with hydrochloric acid compared to a magnesium ribbon strip? Since we know that magnesium reacts with hydrochloric acid to give us magnesium chloride, which is a solution, and hydrogen gas, we can measure the rate of production of hydrogen gas to determine the rate of this chemical reaction. By that, if we took 2 grams of magnesium powder and 2 grams of magnesium ribbon, we would say that 2 grams of magnesium powder has a higher surface area exposed for reaction compared to 2 grams of magnesium ribbon. 2 grams of magnesium powder, for that reason, will exhibit increased rate of reaction of rate of production of hydrogen gas when added to 0.5 molar hydrochloric acid solution compared to the reaction of 2 grams magnesium ribbon with the same 0.5 molar hydrochloric acid solution. We are maintaining the molarity of hydrochloric acid so that at all times we have the same number of reactant particles of hydrochloric acid. We are also maintaining the same mass of magnesium ribbon so that we compare the different surface areas of magnesium when we have a ribbon and when we have the magnesium powdered. Let us look at the rate of production of gas in the sense of a plotted graph. On our vertical axis, we want to plot the volume of gas being produced in cubic centimeters, and on the horizontal axis, we want to consider the time taken to produce that particular volume of gas. We have 2 graphs. The first one, we would want to consider this production of gas when we have 2 grams magnesium powder reacting with 0.5 molar hydrochloric acid, and on the other side we want to consider the same 2 grams magnesium, but this time a ribbon reacting with 0.5 molar hydrochloric acid. we'll want to assume that the volume of hydrochloric acid is the same for both reactions, so that we can say that probably we are reacting 2 grams of magnesium on both sides with 20 cubic centimeters of 0.5 molar hydrochloric acid solution. At the beginning of the experiment, there is no production of gas, and therefore at time 0, the volume of gas produced is 0. However, as time progresses, we'll have the first plot for both curves. But let us look at this. If we consider the reaction of the powder, we'll see that for that first plot, the volume of gas produced is higher than that of the reaction of the ribbon with the hydrochloric acid. In that same vein, when we have the second plot, we'll still realize that for that plot, the volume of gas produced is still much higher than the volume when we have the magnesium ribbon. Again, when we plot the next, when we put the next plot, that one too for the powder is much higher than the one for the ribbon. And if we maintain our dotted line, we'll realize that now there seems to be no more gas being produced when we have the powder, so that we have the two plots lying on the same plane, and that's when the ribbon also produces its maximum amount of gas. So we can say that with the powder, the reaction stopped by the time we had this fourth plot, but for the ribbon, the volume of gas was still low and the maximum was only reached at the fifth plot. So what does this tell us? We can say that there is a higher rate of production of gas when we look at the reaction of 2 grams magnesium powder with a 20 cubic centimeters of 0.5 molar hydrochloric acid, yet there is a low rate of production of gas when we have 2 grams of magnesium ribbon reacting with 20 cubic centimeters of 0.5 molar hydrochloric acid. If we consider then the curves for the two reactions, that is the shape that we would get. The shapes of these curves is significant because the shape indeed tells us how the rate of reaction is. If we were to work out the gradients, we'll find that this particular point is steeper than this particular point. In other words, the curve for magnesium powder would be very steep, while the curve for magnesium ribbon would be gentle. A steep curve, therefore, should be indicating a high rate of reaction, whereas a gentle curve would indicate a low rate of reaction. If we combine the two curves in one grid, then the steeper curve will show a high rate of production of gas, while the gentle curve will represent a low rate of production of gas. Remember, when talking about the rate of a chemical reaction, it's important that we look at it in the light of collision theory. Therefore, a large surface area results in more collisions being successful, leading to a higher rate of reaction. A small surface area results in fewer collisions between reactant particles being successful, hence a lower rate of reaction. Look at this exercise to summarize the concepts that we have learned in this part of the topic. We want to consider that the change in mass for a reaction between 5 grams marble chips, which are actually chunks of calcium carbonate, and 20 cubic centimeters of 1 molar nitric acid was being recorded at room temperature. You are asked to plot the kind of curve that you would expect to observe if the mass of the reaction vessel and its content is plotted on the y-axis against time on the x-axis, and remember to mark that curve as A. On that same axis, plot the curve expected if the 5 grams marble chips is replaced with 5 grams calcium carbonate powder, and mark that curve as B. Let us meet during revision class to see if you tackled these questions correctly. Thank you for tuning in and have a beautiful day.